All right, good morning. And today we are going to do that fourth example from yesterday's notes page. So 6.2. If you weren't here yesterday, you want to go back and watch yesterday's video. But example 4 here. The first thing we want to do is draw our triangles because we know we are going to be trying to solve for the sine of A, sine of B, cosine of A, and cosine of B. We are trying to find those four things, okay? And we already are given sine of A. This is 2/3. And then it tells us that it is in quadrant 1. Now here, we are trying to find the sine of A minus B. So if we remember our trig identities, let's see down here. Sine of A minus B right here, sine of A times cosine of B minus cosine of A times sine of B. So that is our end goal here. We are trying to find those four things. And we already have one of them, but we need the other three. All right, so we start by drawing this picture. It's in quadrant 1, so it's somewhere up to the right. And we know this is angle A. It is a right triangle. The sine SOHCAHTOA, so O over H. O is 2, H is 3. We need to figure out what that bottom side is. So Pythagorean theorem is the easiest way. A squared plus B squared, so A squared plus 2 squared equals C squared. So we'll have A squared plus 4 equals 9. Subtract that, we'll get A squared equals 5, and then A equals the square root of 5. So we go square root of 5 right there. Okay, and from here, then square root of 5, we are trying to find what the cosine is. So square root of 5 over 3. Okay, one triangle down. We need to draw our second triangle. I didn't really leave myself enough room, so let me erase this. Pythagorean theorem, we do need to do it, but I need more space here. So next triangle here, and I'll do triangle B, angle B, and blue. Same thing though. That's our B. Here is our triangle. We know that the O over H, or no, sorry, O over A is what we're given. So O, opposite, that's square root of 57. A adjacent is 8. So let's solve this one. So A squared plus B squared equals C squared. 8 squared is 64. 57 is what we get when we do 57 square root of 57 squared. Combine those, 64 plus 57, that'll get us to 121. We take the square root of both sides, and C equals 11. Okay, so we know then that the sine of B would be square root of 57 over 11. And the cosine of B would be 8 over 11. All right, at this point we can fill it in. So sine of A is 2 over 3 times that cosine of B, which is 8 over 11, minus cosine of A, square root of 5 over 3 times square root of 57 over 11. Okay, we are going to multiply together. So 2 times 8 gives us 16 over 33. 3 times 11 is 33. Minus, we'll get 33 on the bottom again. Since they are both square roots, we can multiply them. So 5 times 57, square root of 285. And at this point, there is nothing else we can do. So 16 minus the square root of 285 all over 33. You could check, can you break apart square root of 285? But we have a 5 and a 57, and that's all we can do. So if you have any questions, please let me know. Please go ahead and Try to solve for some of these. Sorry, that didn't make sense. Go ahead and try to finish up your delta math. So 285, as we said, does break down to 5 and 57. Then 57 does break down to 3 and 19. But at that point, all you have is a 5, a 3, a 19. There's nothing that can pair up. That's why we can leave it as square root of 285. Sorry, I was a little confusing about that. Hope you guys have a great day. And if you need anything, reach out. And I'll talk to you later.